Okay, so we're looking at transformations of curves, and we're going to focus on the two main transformations. There are translations, which is just moving a curve up or down or left or right, and then reflections, which is, as you'd probably guess, it's reflecting through an axis, either x or y. So let's do translations first. So, if we start off with a fairly nice example, let's just start off with our standard x squared graph, looks something like that. So this is the graph of x squared. Our function fx is going to be x squared. Let's look now what happens if we do something to this function. So let's say we want to take our original function, and at the very end we want to just add 3 to the output. Make it slightly nicer 3. Well, all we're doing here is we're taking our original function of x squared, and at the very end we're just adding 3. So what effect is that going to have? If I call this my green function, right? If I were to plot this on my axis, all we're doing is we instead of plotting 0, if this is 0, 0, all we do is before we plot it at the very end, we just add 3. So instead of plotting 0, I plot 3. And if this is, say, x equals 1, and that's x equals 2, for x equals 1, instead of plotting 1 squared equals 1, what we do is we plot 1 squared equals 1, and at the very end, we add 3 onto it. So we do 1 plus 3, and we get 4. And so that point there is going to be our new point. And finally, if we look at when x equals 2, well, we do 2 squared to get 4, and then at the very end, we add 3 onto that, and our 4 becomes 7. And so we get that point there. And the same thing happens on the other side. If we were to do the same thing to those points, what we end up seeing is we get a new curve that looks like this. And what's actually happened is all the points on our original curve have just shifted up 3 spaces. And so what we see is when we make a change outside the brackets, what we get is a change in the y-axis, right? We're only changing the y component of each of those coordinates, right? We're just moving it up in this case. So we move it along the y-axis, and is what we'd expect, right? If we add 3, we'd expect it to shift up 3 spaces. So it's what we'd expect. Let's look now at a different example. Instead of making a change outside the brackets, so instead of doing plus 3 outside these brackets, we'll do plus 3 inside the brackets, and we'll see what happens there. So again, I'll copy out my original x squared function, as we had before. This is my x squared function, slightly wonky, but there we go. And I'm actually going to now do f of x plus 3 inside these brackets. What this means is, instead of the input to my function being just x, the input is now going to be x plus 3. And so, before when the input was x, our output was x squared, right? So all the function is doing is it's saying we want to square whatever the input is. Well, in this case, the input is x plus 3. And so we take that x plus 3 and we square it. Well, it might be tempting to expand on these brackets and plot that function and see what we get, but there's actually a simpler way of doing this to understand what's going on. So, in this case, all we're really doing here, I'll use a different color. I'm going to call this my blue function. All we're doing here really is we're peering into the future, and I'll tell you what I mean by that. So, in this case, if we've got, say, -1, -2, and -3, well, what we do is at the very start, we have to add 3 onto x before we do anything else. If you remember BibMaths, the first thing we do is we take care of inside the brackets. And so we add 3 to x, and then we square it. And so in this case, if I add 3 to -3, I get 0, right? I'm kind of looking ahead almost to 0. And I know, therefore, that 0 squared is just 0, right? I've already plotted that there. And so I just plot that at that point there. And, the mathsy side of things, all I'm doing is -3 plus 3 to get 0, and I'm squaring that. The effect that this has is we're peering into the future, right? We'll do one more example. And so if, say, x is -2, well, I do -2 plus 3 to get -1. I square -1 to get +1. And so that's my output, right? And I plot that output on my graph there. And let's do one more. Let's do -1 as well. So if x is -1, we do -1 plus 3 to get 2. And we then do 2 squared and we get 4. So I'm going to plot 4 at that point there. So, probably what you can see happening is, and if x is 0, we do 3 squared to get 9. What you can see happening is we're recreating this x squared shape, right? We end up with, slightly wonky there, we end up with this new x squared shape. But what we can see is that every single point on our curve is actually being shifted over, right? So everything has been shifted back by 3 spaces. So it's kind of counterintuitive, right? You'd expect that adding 3 inside the brackets will cause our graph to shift up 3 spaces, but it doesn't. It causes it to shift down 3 spaces. And so our rule is, if it's inside the brackets, we change the x-axis, and it's the opposite to what we'd expect. And that's really the only 2 rules that we need to know. And we can actually apply these rules as well to reflections. So we'll go ahead and apply those rules to reflections now. So let's look at another nice example. I'll do a kind of just a random x squared kind of graph. Let's go for this. And in this case, if I want to reflect it, well, let's look at what happens if this is my normal function. This is my original fx, my original function of x. If I do fx and then I take that and I put a minus in front of it, so I make everything negative, what's going to happen? Well, in this case, I'll use a different color. I'm going to call this my blue function. In this case, all we're doing is before, at the very end, before we actually plot our values, before we plot the y component of our values, we actually put a minus in front of it. And so, for example, that point is going to become that point. That point is going to become that point. That point is going to stay where it is. It's just 0. That point becomes that point. And what we can see happening is basically we reflect our entire graph about the x-axis. So it kind of flips vertically. Let's look at one more version of this. So let's look at what happens if we put a minus inside the brackets. And just to go back to this for a second, outside the brackets, we know we're changing the y component of each coordinate, right? So only the y component of those coordinates is changing. Inside the brackets, we know we're going to be changing the x component of the coordinates. So it's going to be changing the horizontal position of each point on this curve. So inside the brackets, I know I'm changing the horizontal component, and I know that essentially what I'm doing is before I actually do anything, I put a minus in front of x. And so rather than plotting for say x equals 1 and getting 0, what I actually do is I plot for x equals -1 instead. Well, when x equals -1, I get this point up here, and so I'm actually plotting this original point. Instead of being in line with -1, I actually plot it being in line with 1. And vice versa, right? My x equals -1, I'm actually going to plot the value of the function when x equals +1. And so I plot for that point there. And so what we see happening is everything, it gets kind of flipped around. So this actually becomes my new function. It looks like that. And what we see happening is every single point is basically flipped in the, I could pick that point there and that point there. That is going to be completely flipped in the x-axis, in the y-axis. So that is translation and reflections. Let's go ahead and look at an exam-style question to put this into practice. So we've got a graph of y equals fx, and we want to do 4 different translations and want to understand what's going on here. So first of all, let's say this is going to be my blue function. So fx plus 3. Well, we're inside the brackets, so we know we're going to be changing the x component of each point on the graph. It's going to be a horizontal change, and it's the opposite to what we'd expect. And so in this case, I know that my graph, my curve, is going to shift down 3 spaces. And so I'm going to end up with something that looks like this. And that point there, rather than being x equals 1, it's going to be x equals minus 2. So that's my first solution. For the second one, for part B, I'm outside the brackets. This is going to be my green function. I'm outside the brackets, so I know I'm changing the y component. It's going to be a vertical change. And all I'm doing is at the very end, I'm adding a minus in front of it, right? So rather than y equals 4, I now have y equals minus 4. 0 is going to stay the same at that point there and that point there. What we end up seeing is we get this new function that looks a bit like that, right? Everything is just flipped in the x-axis. So rather than plus 4, I get minus 4. Right, looking at, I've just put it in the wrong one. Looking at part C, we've got fx minus 3. And again, we're outside the brackets. We know, therefore, we're changing the y component. And it's what we'd expect. Right, so all that's going to happen is our original graph is going to shift down by 3 spaces. So we're going to end up with something that looks like this. Incredibly wonkily drawn. It's going to look something like that. Not much better. There we go. So this original y component of 4 is now going to shift down 3 spaces to become 1. And so we end up with the coordinate 1, 1, which looks about right. That's roughly 1, 1 there. Finally, our part D, let's call this our yellow function. Y equals f of minus x. Well, we're inside the brackets. We know we're going to be changing the x component. It's going to be a horizontal change, and it's the opposite to what we'd expect. In this case, it's just a reflection, really. So, we don't really have to worry too much about the opposite effect here, because there's only one reflection we can do, to be honest. So, all we're doing is we're reflecting in the kind of horizontal direction about the y-axis, if that makes sense. So this is our kind of mirror line. And so all that happens is that point becomes that point. That point there is going to become that point there. Everything is just flipped around. That point on the outside is going to become that point there. And so we end up with a new function that goes through those new points, and it looks like that. And so again, all that's happened is our positive 1 x coordinate is going to become a negative 1 x coordinate. So we end up with minus 1, 4. And that is the end of curve translations. Hopefully that makes sense. Yeah, that's pretty much all that you could get asked in the exam.